China has made history, successfully landing on the unexplored far side of the moon.
For the first time in human history, we have samples from the side of the moon no one has ever seen. And what China found there is not what anyone expected. The hidden face is not a mirror of the side we see every night. It is a completely different world, with different chemistry, different history, and different resources. The moon has two faces, two personalities, and the samples China brought back prove they formed through entirely different processes billions of years ago. But here is what changes everything. Inside that ancient dust, scientists discovered graphene, a material so advanced that humans normally manufacture it in high-tech laboratories. The moon has been producing it naturally for 4 billion years. They found evidence of an ancient magma ocean that once covered the entire surface. They found clues about water hiding in places we never thought to look.
A Chinese lunar mission has found a new source of water on the moon.
And they found proof that whoever controls this hidden hemisphere may control the future of space exploration. China just opened a door that had been locked since the moon formed. And now every major space power is racing to get through it. So what exactly did they find? How did they even land in a place where radio signals cannot reach? And why are governments suddenly treating the far side like the most valuable real estate in the solar system? The impossible landing. The far side stayed out of reach for decades because space is not only distance, it is silence. Think about that for a second. The moon is tidally locked. It rotates exactly once for every orbit around Earth. That keeps the same familiar face pointed toward us, while the opposite hemisphere sits permanently behind a wall of rock. Any radio signal aimed at that hidden side gets blocked. Radio waves do not bend around corners, they simply vanish. That blackout explains why no Apollo crew ever went there, why the Soviet program never landed a working rover on the far side with real-time control. A machine can touch down, but without a communication link, it cannot be guided, corrected, or rescued when terrain turns deadly. But here's where it gets crazy. China built a workaround years before the landing. In 2018, they launched the Queqiao relay satellite and placed it in a special halo orbit where one side could see Earth and the other could see the far side. Suddenly, commands could hop across space like a message passed over a locked door. With that bridge ready, Chang'e 6 lifted off on May 3, 2024. Single mission: touch the hidden ground and bring part of it home. No joystick, no pilot, only onboard judgment. The most dangerous moment was not launch or return. It was the final descent into a place shaped by destruction. The target? The South Pole Aitken Basin, a wound on the moon stretching 2,500 kilometers across, 8 kilometers deep, formed over 4 billion years ago when an impact so violent it almost cracked the moon's crust, tore into the surface. Professor James Head at Brown University called it like a treasure chest of coins from different parts of the moon. Now, most people don't realize this. As the lander descended, Earth lost the ability to guide it in real time. For roughly 15 minutes, Chang'e 6 was completely on its own, falling toward uneven ground filled with shadows, steep slopes, and boulders the size of cars. Onboard AI scanned the surface as it dropped, comparing live images with hazard maps. Each second, adjusting thrust, changing angle, rejecting unsafe landing zones. Fuel burning away, gravity pulling harder, dust thrown up by the engine's blinded sensors. The low gravity made every movement unpredictable. Even a small bounce could have ended everything. Yet the guidance system kept correcting, choosing stability over speed, making decisions no human could make fast enough. Then contact. The basin remained silent. But the mission had crossed its first impossible line. China had just done what no nation, not the United States, not Russia, not the combined space agencies of Europe had ever accomplished. They landed on the hidden face, and they were about to dig. If discoveries like this keep you up at night, hit subscribe, because what they found in that ancient dust is about to change everything. What the samples revealed. Chang'e 6 did not pause long. Within hours, its drill extended into soil that had not moved since the early solar system. A robotic arm followed, scooping surface material into sealed containers. 53 days later, the return capsule punched through Earth's atmosphere and landed in Inner Mongolia. 4 pounds of rock, 53 days in space, and one discovery that rewrites the textbooks. When scientists at China's National Astronomical Observatories opened the container, Professor James Head was among the international researchers watching. He later told CNN the samples were a gold mine. Here's the catch. They did not look like the pale dust brought back by Apollo. They were darker. And that tiny visual clue pointed to something massive. The lab results hit like a verdict. The far side ran cold while the near side burned hot. 2 different thermal engines inside one world. Researchers focus on a group of elements known as creep: potassium, rare earth elements, and phosphorus. These elements act like a heater because they are tied to radioactive decay that releases energy over billions of years. Apollo-era samples from the near side showed strong signs of this heat-producing mix. And get this, NASA's measurements show the near side crust is about 40 kilometers thick. The far side, 60 kilometers. That extra thickness works like a lid, harder for magma to break through. Dr. Richard Carlson, Director Emeritus at Carnegie Science, explained it this way. The giant impact that created the moon left behind 2 fundamentally different hemispheres. One half stayed more willing to melt. That melt reached the surface again and again, building the dark Maria we recognize at night. The far side had less of the heat-producing mix and a thicker crust, so it kept its bright highlands and stored its history in battered stone. That is putting it lightly. The moon followed 2 different paths from its earliest childhood. The impossible material. But the chemistry was just the surface. What they found hiding in the carbon changed everything we thought we knew about what the moon has been doing in silence for 4 billion years. Professor Wei Zhang and his team at Jilin University made the discovery that stopped everyone cold. Under the electron microscope, they found graphene, sheets of carbon only 2 to 7 atoms thick, naturally formed in the lunar soil. Here's the deal. On Earth, graphene requires sterile laboratories, precision equipment, and carefully controlled chemical processes to manufacture. It is one of the strongest materials known to science. Lightweight, electrically conductive, revolutionary for electronics and materials science. And the moon has been making it on its own, in total silence, for billions of years. So here's the question nobody's asking. How? The answer is violence. The lunar surface takes constant punishment, radiation, vacuum, endless impacts. Without an atmosphere to burn them up, micrometeoroids strike at extreme speeds. Even grains of sand deliver enormous pressure for split seconds when they slam into rock. In that instant, carbon in the soil gets squeezed, heated, and forced into new patterns. Then it cools so quickly the structure locks in place. The energy comes from shock waves that compress matter and nudge atoms into tighter order. Professor Zhu's team confirmed the process. Iron-bearing minerals in the lunar soil catalyze the transformation when volcanic eruptions and solar wind interact with carbon-containing materials. Think about that for a second. If graphene can exist naturally in regolith, then lunar soil is not just a problem to sweep away. It is a raw supply that could be refined where it is found. Some researchers quietly speculate this changes the entire economics of lunar settlement. Graphene could support tough composites, protective coatings, and conductive parts, all manufactured from local materials instead of hauled from Earth at enormous cost. Proof of an ancient ocean of fire. Chang'e 6 did more than explain two different lunar faces. The samples pointed back to a time when the moon itself was liquid. The leading origin story describes a giant collision. A Mars-sized body struck the young Earth and threw hot debris into orbit. That debris gathered into the moon. In that aftermath, the newborn moon would not have been a cool boulder. It would have been a glowing globe of melt. This picture is known as the lunar magma ocean. As the melt cooled, dense minerals sank while lighter feldspar-rich crystals floated upward like foam on a black sea. That floating layer slowly froze into bright highlands. And get this, the Chang'e 6 samples carry fingerprints of that ancient crust, material that should only exist if the moon once sorted itself in a molten state. Dr. Yuki Qian, a planetary geologist at the University of Hong Kong, noted that the South Pole Aitken Basin acts like a natural excavation. The massive impact dug so deep it tossed lower crust and even mantle-related minerals toward the surface, then locked them in place in a dry, airless archive. A 2025 study reported primitive lunar mantle olivines in the returned soils. The moon stops being a flat face in the sky and starts reading like a layered body with a violent childhood. What they're not telling you. Here's where the official story gets interesting. The far side samples also reopened a question people thought Apollo had closed. Where could water hide on a moon that looks bone dry? One answer sits in glass. Impact glass beads, droplets made when meteor strikes melt rock and spray it outward, can trap water when solar wind hydrogen bonds with oxygen in the glass. A 2023 study estimated these beads could store significant quantities across the lunar surface. Another answer is water locked inside minerals. Researchers studying Chang'e 5 soils reported a hydrated salt containing about 41% water by weight. That is not a trace. That is industrial grade. But here's the catch. Early analysis described Chang'e 6 samples as drier than many near-side samples. The moon stores water unevenly. Location could decide whether a future base thrives or struggles to survive. Now, most people don't realize this. The real prize might not be water at all. It might be helium-3, a potential fusion fuel so rare on Earth that it practically does not exist. The lunar surface has been soaking up solar wind for billions of years, and some of that wind carries helium-3. The numbers sound like a jackpot, but extraction remains unproven at scale. So here's the question nobody's asking. Why is China racing to claim this region specifically? NASA identified 13 candidate landing regions near the lunar South Pole for Artemis missions. Shackleton Crater sits in that neighborhood, rim lit much of the year, interior dark enough to preserve volatiles. China is building toward the International Lunar Research Station. Recent reports link Chang'e 7 and Chang'e 8 to scouting South Polar water ice and testing local resource utilization. The official story says this is pure science. But the data suggests something bigger. The language has shifted from footprints to infrastructure. Major powers now plan as if they are moving in, with maps, timelines, and hardware that treat the lunar surface like a future supply chain. Professor Head put it bluntly, the complex mission goes through virtually every step required for Chinese astronauts to land on the moon. The hidden face speaks. The moon is no longer a quiet lamp in the night sky. Chang'e 6 turned it into a place with stakes, resources, and rivals. One mission carried home 4 pounds of soil and rock after 53 days. That return changed the meaning of what people assumed. The samples hint at a moon built from extremes. One hemisphere burning hot and pouring lava into dark plains, while the other locked its history inside bright highlands. They reveal graphene forming naturally through violence, water hiding in glass and minerals, an ancient magma ocean crust exposed by the largest impact basin in the solar system. And get this, Professor Brad Jolliffe at Washington University called the Chang'e samples critical for closing a 2 billion-year gap in our understanding of lunar history. That gap matters because the moon is a frozen record of what the early solar system looked like, the period when life emerged on Earth. Back in the 1960s, the story ended with a footprint and a photograph. Now it continues with power plants, factories, and hardware meant to stay. The race is not about flags anymore. It is about who controls the resources, who writes the rules, who builds the first permanent infrastructure on another world. The far side was not empty. It was waiting for someone to listen closely. Should humanity mine this world for energy and materials, or set strict limits before the first permanent base arrives? And if graphene can be harvested from dust, could it become the backbone of real lunar cities? Comment your view below and subscribe now, because the next discovery from these samples could drop any day, and you don't want to miss what they find next.